not responding. So it looks this app is not working today. I send you the meeting link so you can log into the meeting link to look at the screen. Okay. Yes. I just not responding whatever I try. Yeah. Oh, okay. I think maybe it worked. Okay. Sorry for the delay. Okay, last time we stopped at the cross validation. Oh, we used just a regular training split, and to use the training set and the testing set for the algorithm. Well, we stopped it here and we introduced the concepts about cross validation. So when it's k equals 5, it splits the data into 5 folds. So for each time, it takes 20% for testing and 80% for training. And if k equals 10, then it will divide into 10 blocks, and it takes out 10% for testing and 90% for training. So this time, instead of using this testing training method, we'll use the cross validation. Oh, it's pretty easy. So we just follow this format. So far, we have made everything easy, right? All these algorithms seems very easy to implement at least. Yeah, I specified this classifier. I just tell it model 1. Okay, model 1, and instead of using this training set, we use a cross. We can work on the code together. Okay, cross validation score, and in this method, we tell it first parameter is we tell it the model, the algorithm we want to use. The algorithm we use is the model 1. Then we tell it the X data and the Y data. X data here, last time we used the scaled, okay. The Y is Y, and next one we need to tell it is how many folds we want to use. Usually you use 5 or 10, each is fine. It depends on how big is your data set. If your data set is over 10,000 entries, okay, you don't even need to use this. You have sufficient data to train and to test. You don't even need to use this cross validation. But if it's only 100 data or 1,000 data, then we will use this cross validation. And if it's 1,000, you can use the KC folds equals 5, or maybe if it's 100, you can use the folds equals 10. So it will have instead of one training, one data set here, you can multiply, right? Multiply into 5 times. I will multiply into 5. Okay. So here I have 150 data, so I use 10 folds. Okay, and the next one we need to tell it is the scoring method. So far we have learned the accuracy, only learned the accuracy for classification, and we learned the R-square for linear regression and for numerical target variables. So right now I just use accuracy. Okay, and then I call this CV scores. So what this one generated is a list of CV scores, a list of accuracy scores for each run here. It generated for each experiment, it generates an accuracy score. Right? So this one, accuracy score. So this one, it should be a list of 10 accuracy scores. One should be 10 accuracy scores. If we print it out, let's check. Okay, you see, gives us 10 accuracy scores. Each accuracy represents one experiment. So what we want to get is for the final score for k equals 1 is what we want to get. We want to get the average. What we want to get. This represents the accuracy score for each experiment here, right? And we said, like when you use a training testing split, each time you change the line or change the random states, it gives you one accuracy score. And each accuracy score should be different because it takes out the different training data set and testing data set. Rotate, right? Rotate. So every time it gives you one accuracy score, what should be the final accuracy score of all the experiments? You want to get the average, yes. So this returns a list of accuracy score, and we use the mean score. We use this mean as the final accuracy score for the KNN model when k equals k nearest neighbor model when k equals 1. So with this, I'll just leave it here. And with this, we can get to the mean, right? You get to the mean. Okay, so this gives us 90.6%. That's the accuracy score for k equals 1. Now, what we want to do is to find the optimal k. Right? We said we want to find the optimal k. So what we need to do is to repeat this code for k from 1 to k from maybe how many 150. We said the number should not exceed the number of rows, and usually you find the optimal k when k equals the square root of the total number of rows. So we can iterate the k from 1 to maybe 20. Right? Are we all good here so far? So what we need to do is to reuse this code and then get a loop for k equals 1 to k, from k equals to 1 to k equals 20. Yeah, we can actually put this in like a maybe a function, or we can just use a for loop for k in. So first we have to define the k values. Actually, the k just a list, okay, an empty list. So what should this list be? As 3 classes, it should be from 1 to 20 and excluding the numbers 3 fix. We do I cannot use numpy range, right? Can I use numpy range? No, it only gives you like 1, 1, 4, 1, 4, 6, and it may not work. So I'll just use this the iterator, and for I from 0 to 20, if I divided 3 equals 0, if I is a no, if I is 3's multiple, so then we skipped it. So which means that if I is not 3's multiple, then K, we put it into this K list. Let's print out K. See if it's what. It didn't skip. Oh, what's wrong here? It didn't skip. I didn't add it yet. Will it work? And I want to skip 0. I want to skip 0. So okay, yes, that's a good list. A good 1, 2, and it skip 3, 6, 9, because there are 3 species here, 3 types. Are we all good here? Yeah. Okay. So now I can use this K, and for K in, no, for I in K, okay. Let's see that for K. And then I repeat this code. Repeat this code, so this one should change to instead of fixed number 1, we are iterating it, right? Iterating it from number 1 to this number. So this one should have changed to what? This number 1 should have changed to. Just change it to 1 number. Yeah. We are iterating from this 1 to 19 for I in this list, K list. So n neighbors equals 1. What's the answer?
Or would it be 8 since you took away 3?
Yeah. So we are finding the optimal K. What we are doing is to iterating all the Ks and then to get the K value with the highest accuracy score. So, so in the old code, in the code here, I fixed the K equals 1. So now I'm iterating the K from 1 to 19. So then here, this A neighbor should equals to, yes, I. And model is model 1. Good. And then I want to get to the score, CV scores, and the mean value of the score. However, here, because I want to get to all the mean accuracy of these models, so this one gives me a number for the accuracy score when n equals 1, when I equals 1. So if I want to store all these, save all these accuracy scores, and actually I have to use another list to save these scores. So It should be accuracy scores and append. So I believe it's good. Let's see. Okay. Looks fine here. This is the average score when k equals 1, and then it goes from it goes down a little bit and it comes up, and the highest score is here, k equals 4. So here this highest accuracy score happens when k equals 4. So that it looks good. You can put the k value and the accuracy score in a data frame, and then you can order it, right? Order it in descending order to find the optimal k. Okay, I guess that's finish our mission for the k nearest neighbor. And further, you can not going to order this in descending order. Okay, it's pretty easy for us, and then you can plot it with line plots. I don't want to go over those 2 steps. It's pretty easy for you all. But one issue we didn't address is oftentimes that the data set is imbalanced. Here, all the species, they have the same number of species. So we just didn't address this imbalance problem. What did we mention? Some techniques to address the imbalance data set. One is to oversample or undersample, right? Yeah, that's one thing we did. And when you split the training data set and the test data set, what did you do? There's a parameter that you make sure, hey, not all the hey, cancer cases go to the training, and all the non-cancer cases go to the testing. What's that parameter? Yeah. Yes, stratify. Stratify, yes. So in training, in this method, the training testing split, you use this stratify. Here, stratify to define this. And with this cross verification, cross validation, you can also do that. So this method is called stratify the k-fold. Stratify the k-fold. Here, I did it to the side. Instead of using, I'll use this to demonstrate it. Okay, instead of using 10, this number 10, you use number like a k. So you can use k equals 10, and then this one replace the k. That's okay. So, but here we are not a fixed number called 10. So you use this method called stratify the k-fold, and then the number of split is still 10. And then you use this K for to replace the number 10. And that will stratify the data set. Okay. So this method should need to be imported again. So this one in this way, it will stratify. Probably something wrong here. Okay, stratified K-fold and split. And split. Yeah. Some of this score doesn't look real. Actually, score equals 1. It doesn't look right. But this model for this training set could be quite accurate. Although this number doesn't look very real. Accuracy score equals 1. Okay, so we have learned the 2 methods: oversampling, undersampling, and then you stratify it when you do the cross validation, all training testing split. And there's another technique we can use to evaluate imbalanced data set when you use imbalanced data set. So that is not to use the accuracy score. Instead, there are some other metrics when you evaluating a model, a model for imbalanced data set. So here, for example, here we got a result. Got the prediction result based on a data set for breast cancer. Okay, and we got 2 results for 2 models. For example, this is for KNA, this is for decision tree. If we evaluated these 2 models based on the accuracy score, so see, if we evaluate it based on the accuracy score, what is the accuracy score here for each model? It's model A, okay. Model B. Who can tell me the accuracy score for each model? This is the testing 0, negative, positive, and then the prediction result, negative, positive. So we calculate the accuracy score. What is the accuracy score for this data set or for this model? It's a accuracy score is the ones that are predicted right. So what should be the score? 0, 0, and then 1, 1. Here. You can tell me, you can help me with the formula. It should be 6, 5, 6, 8. And then over the total. Yes. And this B accuracy score. Yes. So if you get to the result of these two number, what will be the result? Which one is better? The one equals 99 on the top. It's also 99 on top. So these two models, the accuracy score is the same. So these two models really has the equal effect, exactly the same. So we have to look into other metrics. We can look here. We are predicting number of breast cancer patients, right? What we really care about is that we want to find out all the breast cancer patients. We don't want to miss anyone who have breast cancer, but they are not predicted. They are predicted negative. You don't want to miss those. It has a high risk if you don't treat them. Right? So we want the number here. We want the number of called recall score. Okay. So what we said, we want to predict all the number of breast cancers correct. Here, what should we do? Or what will be the formula? How many actually had breast cancer? Testing data set, how many actually had breast cancer? 6 plus 68. Now, how many were predicted right? 68. So the score is 68 divided by 6 plus 68. So this number is very important to us because we don't want to lose anyone that are breast cancer patient. Right? So we care about this score actually more than accuracy. And the same, we get this score for this model, B model. The score for this B model is 65 divided by 9 plus 65. So with these scores, this 68 divided by 74. So this is a 65 divided by 74. So which one looks better? Which model looks better now? This is called a recall, okay? This is called a recall score. So by the recall score, which model looks better? First one, yes. I predicted, find out more patients that actually has breast cancer. I was able to find them, all of them out, most of them out. And this one, find 65 out. So this one looks better now. But in another aspect, so if we look at this one, with those yes, so for all those that are predicted as having breast cancer, we don't want to, hey, for all those predicted as breast cancer, we don't want to have a wrong diagnosis. Some maybe, well, this group represents, hey, they actually don't have a breast cancer, and they are predicted as the predicted. Right? This is what 9%, they actually don't have a breast cancer, and then they are predicted as breast cancer, and they may have further tests to confirm that. That's okay. But if they don't have further tests, hey, they may be given treatment. Or we don't want to treat them wrong, give them medicine if they don't need it. So what score? This score is also very important. So we want to, for all those predicted as the breast cancer, we want them to be precise. So I'll write this formula out first. So for all those that are predicted as a breast cancer, we want this to be correct. Nine person, they may be treated wrong as a breast cancer patient, and they actually don't have breast cancer. So what we want this score to be high also, and this number to be low. These are diagnosed wrong. 9% was diagnosed wrong. So we want this score to be high as well, and reduce the number of patients that are mistreated. Right? So with this score, it's called precision. Okay, precise or precision. What? Precision. Okay. It's called a precision score. So with this score, which model is better? Say 77. $65 divided by 6 plus 65. Six plus 65. So with this number, actually, it's I don't know how to calculate it. But actually, this P2 is better. This P1 is smaller than this P2 actually. The P2 is better. Okay. I ran calculator before the task. So this is better. But for this recall score, this one is better. So it depends on which one is very important to you. If you think hey, it's okay to misdiagnose them, to classify some of the negative patients as the positive, and you will run more tests to find them to confirm that confirm them that's okay. Then you emphasize the recall score. You take this recall score. But if we want to find the balance, we want both to be high. To find a balance between these scores, because now one has the higher recall score and one has the higher precision score. So if we want to find a balance for both scores are high, then we have another score called F1. F1. Okay, F1 score is used to find the balance between the recall score and the precision score. So the formula is 2 times the recall score times the precision score and divided by this recall score and the precision score. Oftentimes we want to find a balance between these two scores, and we use this F1. In some situations, for example, like the fraud detection, whether this transaction could be fraud or not. So if there's any fraud transaction, you want to any fraud transaction, you want to find them out. So this recall score is very important. And some of the transaction, hey, they may be classified wrong as fraud transaction, right? But it's fine because you send a message to the customer to confirm, hey, this is your real transaction, and like will be received on the phone. If I shop at not a Kroger, not a Walmart, but a convenience store at Kennesaw or in Alabama, then the BOA will send me a message, hey, is this your real transaction? I want to confirm with you. So we want to find out all the fraud transactions, but it's okay to misdiagnose, misclassify this as fraud. I don't care about the score, really. I'll take the score. I'll use the score. But in some cases, you want to find that balance, like the breast cancer or some other test. So this is an important concept I want to add today. And in the assignment for the last question, you will also be asked to use the F1 score. I should ask you all to explain that F1 score. I didn't. It's okay. We'll do that in another assignment, maybe in the project. So here we conclude about the k-nearest neighbor algorithm. It's widely used because it's easy to understand and easy to apply. There are only two metrics to provide. One is the number of k-value, and then the metric distance. This actually default metric is the Euclidean distance, so you don't even have to specify this in most cases, right? And it support multiple classes, not just binary classes. And no training period thing. With the k-nearest neighbor, you only want to find the optimal k-value, and then when the algorithm, when you give it the k-value, it calculates its nearest neighbors. And not like a logistic regression or the linear regression we learned. They use the training set and then they generate a formula, and then they apply this formula to the testing set. But k-nearest neighbor, it doesn't have a formula at the end. It uses the k to calculate all the nearest neighbors. So some say it makes the KNN algorithm faster. I don't agree with that, because with this model, you still have to calculate each testing data and testing data. So each entry, you have to calculate its nearest neighbor, right? And with this with this logistic regression or linear regression, then you have the model, you have the formula, and you just need to calculate the formula instead of calculate all the neighbors around this. So I think this is not an advantage, but disadvantage of this algorithm. If you want to predict a lot of the testing data set, it will be slow. So that is like this says, the cost for prediction is very high. Actually, if the testing data set, if you want to predict a lot of data, this cost is actually higher than other algorithms. So it doesn't work with a big number of features, and also hard to work with the categorical features when you calculate the distance. We mentioned at the beginning, it's the cost. But it's still a good algorithm that we can practice and learn. So far we have learned the two algorithms, and on Monday's class I'll introduce the division tree and It's also easy to understand. Also, it represents some other other algorithms like the random forest. It's also based on decision tree. So we'll still have lesson on Monday. But for next week and the week after next week, you will be working on the project, the second project. So you will get the instruction to help you, to structure your report, and pretty the same as the first one, but a little more complicated, but pretty same. You follow the structure and then generate the report. Okay. And in the second project, I'll also ask you all to explain your report in a video or in audio. Do you all sometimes record a video? Like record a video, post on YouTube? Record a video. What software do you use? Any free software you use?
We could just like,
Well, you have to talk over the screen, so you cannot use a phone to record the video.
yeah, you can use your phone and put it like on YouTube as the list.
But like in our assignments, I want you to talk over your report. Not to record yourself talking.
Oh,
but
you
you
want
have
to
to-
see the report?
Yeah, you have to like explain your report to me. Yeah, so we cannot do it on the phone. We don't have any, we didn't use any free software.
You can use Zoom or Google Meet and share your screen and make some voice, and you can record the Zoom screen.
What's that software?
Zoom or
The free?
for 1 or 2 person. It is not free for more than 3 person.
What's that called?
GOM.
GOM?
Yeah, but you can record your voice and screen in every online meeting application. You use the same method to record your voice or screen. You
Okay,
use the Zoom right now.
okay. I'll find the one that works for everybody and then I'll suggest a software. Just need to test all those.